Hey guys, my name is Salah Elsherif, and today I'll be presenting my Module 1 Theoretical and Percent Yield Culminating tutorial. So to begin, I have some memes here over for you guys on the right, and you guys can spend a couple seconds looking at that. I thought I'd add a little bit of sense of humor to my tutorial. So to begin, chemical reactions in the real world don't always go as planned on paper, right? In the course of an experiment, many things will contribute to the formation of less product than would be predicted. Besides spills and other experimental errors, there are usually losses due to incomplete reactions and undesirable side reactions. Chemists need a measurement that indicates how successful a reaction has been. This measurement is called the percent yield. So, to compute the percent yield, it is first necessary to determine how much of the product should be formed based on stoichiometry. This is called the theoretical yield, the maximum amount of product that could be formed from the given amount of reactants. The actual yield, however, is the amount of product that is actually formed when the reaction is carried out in the lab or in a classroom setting. The percent yield is essentially a ratio or comparison between actual yield and theoretical yield expressed as a percentage. So here I have a diagram for you guys to better visualize or illustrate this concept. So after the experiment, you calculate the actual yield. After a calculation, you calculate the theoretical yield, and then you combine these two to determine your percent yield ratio. So here's our percent yield expression, as we all know. So percent yield is very important in the manufacture of products, like pharmaceutical products, for example. Much time and money is spent improving the percent yield for chemical production. When complex chemicals are synthesized by many different reactions, one step with a low percent yield can quickly cause a large waste of reactants and unnecessary expenses. So typically, percent yields are understandably less than 100% because of the reasons indicated earlier. However, percent yields greater than 100% are possible if the measured product of the reaction contains impurities that cause its mass to be greater than it actually is. But you guys have to understand that this is a pretty rare occasion. Moving on to the limiting reagent. So basically the limiting reagent or the limiting reactant essentially in a chemical reaction is a reactant that is totally consumed when the chemical reaction is completed. The amount of product formed is limited by this reactant since the reaction cannot continue without it. If one or more other reactants are present in excess of the quantities required to react with the limiting reagent, they are described as excess reactants. You guys also have to really understand that the limiting reagent must be identified in order to calculate the percentage yield of a reaction. This is because the theoretical yield is defined as the amount of product obtained when the limiting reagent reacts completely. Hey guys, so let's go over an example. So given the following reaction, magnesium hydroxide plus 2HCl react to make MgCl2 plus water. So how many grams of MgCl2 will be produced from 12 grams of magnesium hydroxide and 42 grams of HCl? So first, let's start by listing our knowns over here. So we have the molar masses and the masses of each of our reactants. And if you guys realize, there are two reactants in this equation. So we have to determine which one is the limiting reagent to calculate the mass of this product over here. So you guys know the mole equation, which is mass over molar mass. So I'm sure you guys know how to do it. So after we use this equation, the moles of each of our reactants turn out to be 0.206 moles of MgOH2 and 1.15 moles of HCl. So using this mole, we're going to use these moles in our mole ratio to determine which one is the limiting reagent. So we have the moles of Mg hydroxide over here over the moles of HCl. So the mole ratio, according to the equation, is 1/2, as you guys know. And say, let's disregard the numbers in our specific chemical reaction here, and let's use the moles of magnesium hydroxide to determine how many moles of HCl we actually need to react with this number of moles, and compare it with the number of moles we have in our specific reaction. So after cross-multiplying over here, it turns out that we only need 0.402 moles of HCl to react with magnesium hydroxide in this specific quantity. So if we compare it to the number we have over here, this number is relatively larger, which means that our limiting reagent is magnesium hydroxide. So now that we know magnesium hydroxide is our limiting reagent, we can use mole ratios again to calculate the mass of this one, of the MgCl2. So now that we have moles of Mg hydroxide over the moles of MgCl2, we can use mole ratios, which is 1 over 1, according to the equation again, 1 over 1. We can calculate the moles of MgCl2 to be 0.206 moles as well. So overall, moles of MgCl2 are 0.206 moles. So now that we have the moles of our product, we can use this equation again to calculate the mass. So we have the mass of MgCl2 is equal to the moles times the molar mass. So our moles, as we know, are 0.206 moles times 95.21, because that is the molar mass of magnesium chloride. So the final answer would be 19.6 grams. And this is essentially the final answer of our following reaction or overall question over here. But say I gave you guys the actual yield of a laboratory setting that performed the same chemical reaction over here. So say I gave you guys an actual yield of 18.9 grams. And I told you guys to find the percent yield. So first we'd use the percent yield expression we know, which is Py, or percent yield, is equal to actual yield over theoretical yield times 100%. So plug in our numbers, 18.9 grams over 19.6 grams times 100, and essentially our percent yield will be 96.4%. And this is a relatively high percent yield compared to other chemical reactions. So moving on to our real-world application of this Module 1 concept of pharmaceutical production. So the world of pharmaceutical production is an expensive one. Many drugs have several steps in their synthesis and use costly chemicals. A great deal of research takes place to develop better ways to make drugs faster and more efficiently. It is also important to consider, guys, that studying how much of a compound is produced in any given reaction is an important part of cost control. So many employed chemists in pharmaceutical companies have to ensure that a certain threshold of percent yield is met when synthesizing certain drugs to maintain optimum efficacy and safety as well. So as an example here, Pfizer, a pharmaceutical company that requires 93% yield for specific selective serotonin reuptake inhibitors, and these are like forms of antidepressant medication if you guys didn't know. So with a given or actual yield of 6.7 grams and a theoretical yield of 7.1 grams for synthesized antidepressant medication, will the percent yield suffice Pfizer's requirements? So to start off, we have to use our percent yield expression, which is over here, and sub in our values, so 6.7 over 7.1 times 100 to come up with the percent yield of 94.4%. So according to Pfizer's requirements, 94.4% is enough to ensure that this antidepressant medication will be safe and efficacious as well. So thank you guys for listening to my tutorial, and here are my references.